Hi, this is Kunal Lal for Digital Dentistry Forum. Today I'm presenting a case of digital smile rehabilitation with CEREC and InLab. Why rehabilitation? Because there's a lot more to doing these cases than just design. Here's a patient with intrinsically discolored teeth. He wanted his teeth to be very light in color. His teeth were in relatively good position. We did a smile design mock-up using Keynote. This was done by Step Toothmaster Bay from CDI Science, who also did the final restorations on this case. So his teeth were in good position. There was some lengthening of number 9 that we wanted to do, and some gingival architectural corrections to be done with a laser. So intraoral imaging was completed with CEREC, upper and lower arch, and this was sent over to InLab 18 with the Connect portal. And this was just a diagnostic design. After completing the design, we go back to the administration phase and virtually seat all the restorations. This is equivalent to a virtual diagnostic wax-up. Then we use the InLab Splint software, and we designed a Michigan splint. Insertion axis was changed all the way to the facial, and spacer thickness was kept at 0. The outline of the splint was scalloped on the facial. And this was exported as an STL file to be printed using a 3D printer. Now, we can also easily go back and change the tooth form and design the case with different shapes. And this is a very simple procedure. This allows us to create multiple mock-ups for the same patient with minimal effort. And same thing as restorations virtually seated, a splint fabricated and designed. This is what an STL looks like on a Mac. And preform software was used. Now the interesting thing here is I used a flexible material made by Form Labs. I printed 2 digital smile rehabilitation matrices and the maxillary diagnostic model in the flexible material. This was placed in the form wash. I find this to be the most efficient way to clean my prints. And this is the form cure. So after letting the alcohol dry, I set it in the curing unit with the table, and this allows for easier removal. This goes back in the curing unit for another 15 to 20 minutes to allow complete polymerization. Because it's a flexible material, you can just pull off the base from the supports The model is flexible, so I poured some stone to add structural rigidity, leaving the surface flexible. A model trimmer was used to remove the residual supports. The matrices are flexible, and you can have multiple matrices made to reflect different tooth shapes and be able to visualize in the patient's mouth what is most aesthetically acceptable. Normally, we just have one option. Now, when it's an additive wax up, meaning you're making the teeth longer or bringing them out facially, this works well. You can use the matrix in the mouth, or using this technique, have them pre-made and just seat them in the mouth. But when you're trying to move teeth further in, lingually, or make them shorter, you have to prep the model either manually or virtually, otherwise the mock-up becomes too thin. Now these can only be tried in after on the model or after the initial tooth preparation. The matrices fit on the pre-op and the virtual prep model. You get multiple sets made up, and you can try them in the mouth. In this case, they were made on the virtual prep model. I did not adjust or relieve it internally to seat better. But this just goes to show how you can preview multiple trial arrangements. So tooth preparation was carried out. Some gingival crown lengthening was required on teeth number 7 and 8. So we used a Soleil laser. We also used the Splint software to fabricate a guide that we transferred with a marker how much we wanted to use for crown lengthening. That then also helps as a tooth reduction guide. There was an implant in number 4. You can also print your virtually prepared model. Here's our temps that were printed using the Next Dent crown and bridge material. These can be relined intraorally. Then we use CEREC for final impression. Smile design with a facial picture and the avatar were used, and functional movements and articulator settings were adjusted. This was further sent to InLab 18 via Connect. Where the final design was completed using the temps as the biocopy. You can get 3D printed models. This is the Atlantis abutment, which was a gold hue titanium abutment. This is the final restoration. and the day of insertion. Thank you for your attention.